So you go all the way to 170 in your booklet, and the bottom section there is open. So we're going to make sure, if you go, I'm going to zoom out a little bit, you know where the side note is, right under closure? Just do one of these, and we'll answer this if we get to it above it. But we're going to call this expected value. And so we'll define it, a value calculated which tells us if a certain investment bid, contract, or game, so they're all the same, right? Whether we're talking about investment, you're making a bid for something, you want to win a contract. If you're, sometimes as a contractor, you have to pitch, right? You have to put in an estimate of how much the project is going to cost, and the province, the government selects the one that's the best option, right? The cheapest sometimes, not always. So it tells us if a certain investment bid, contract, or game will result in a gain or loss this only works in the long run, i.e. large sample size. So it only works if you have a large sample size. If you play that certain game a bunch of times, that's when this is going to end up being the case. Okay, so expected value, this is what I'm going to say here. If the expected value, there's three options, is greater than 0, then gain is expected. So if the expected value is greater than 0, gain is expected. If it is equal to 0, we call that break even. You're not going to really win or lose in the long run. You're just going to break even. And then obviously, if it's less than $0, it's always dollars, loss expected. This I'm going to box in here. You should probably have this part boxed in. You can just, in your study sheet, the EV, it's greater than 0, win, break even, loss expected. Okay. Formula. Expected value is the probability of winning. This is, and sometimes there will be multiple ways of winning the prize. Like, right? Sometimes when you go to the Red River X, right? If you pop this many balloons, you get first prize, right? If you pop this many, you get second prize, and so forth. So probability of winning the first prize times the gain of winning that first prize. So we go gain 1 plus probability of winning a second prize if it is there, and how much you would be gaining if you won that second prize. And watch what I'm going to do here. This continues on for as many ways as there are to win. You keep on adding that. That's what the ... is. So it's not always going to be there. Most likely it's going to be 2 ways of winning. And then at the end, you go minus probability of losing. Probability that you lose times the cost of playing. This is big. Okay, so I'm going to say gain, right? This is a note here. Gain is the prize minus cost. So if you play scratch and win, anybody play scratch and win? Technically, if you're not 18, you're not supposed to. But if you play scratch and win, let's say you win 10 bucks, right? But you paid $2 to buy it, right? How much have you really gained? $8, right? So always remember that you don't win 10, you won 8 because you paid 2 to play, right? So gain is price minus cost. Remember that. So these gains will always subtract, and that's all. I'm just going to box this in for you. Just note, if 1 in 100 tickets win, then probability of win, I'm going to make it very simple, is 1 out of 100. Therefore, 3 dots like this is always therefore, okay? Probability of losing is going to be what? How many tickets do not win? 99, right? So 99 out of 100. So they will not tell you that. They will just tell you the winning probability. You have to figure out, right, the losing in your head. Okay, so now we're going to go to our booklet. So I'm not going to make you write down any examples. You know that worksheet booklet that I gave you? We haven't used that in a while. The one that had this chart in it. Actually, if you have it closed, it has the deck of cards at the front. But can you please take this out? So it's a deck of cards handout. I'm surprised a lot of you are doing very good with deck of cards. So either your study sheet is awesome or you just know your deck of cards. I don't know what it is, but that's good. Okay, so we go to page 12 in this booklet. Oh, should I say that in the notes? I should totally do that because otherwise you will have no examples. Can we do that here? In our booklets, right under C, page 12 in the workbook. I would add this here, otherwise you're not going to have any examples to go by. Okay. So page 12. And there's a formula again, just in case. I'll make a note here. Often, you will only have one way to win. So you won't always have, multiple ways of winning. So don't always expect to fill in these otherwise. Sometimes it'll just reduce to this, right? Like this is all gone. But you will always have the loss at the end, always. There's always a loss associated with it. And in my formula, I call this the cost. Maybe let's do that here, cost, right? Just so you know, it's the cost to play that you're supposed to put in there. So let's do an example here. A game is being played with one, I didn't make this question, it says one dice, it's supposed to be one die, right? It costs $2 to roll the die. So that's your cost of playing, right? Let's put that right out here. This is the cost to play. If you roll an odd number, you lose the game. I will highlight that. If you roll a 2, you get a $2 prize. If you roll a 4, you get a $4 prize. If you roll a 6, you get a $6 prize. What is the expected value for this game? So we're going to go expected value. Let's look at the winning first. So if we get roll a 2, so probability of rolling a 2, we're going to write that down first. And then you would win a $2 prize, but it would cost you $2 to play. Okay? Plus probability of rolling a 4, we're going to fit that in later. You would win $4, but it would cost you 2. So the cost is always in there like that. Plus probability of rolling a 6. You would win $6, but you would have to pay 2. So you always have to subtract the cost, right? So cost, I'll have arrows going to the first one, to the second one. And the cost is always taken away from the win, the prize. So these are 3 ways of winning. And now that you're done with that, you go probability of losing times the cost, which is $2. Okay. So how about we do it's like an octopus almost here, right? Like cost is everywhere. Cost is everywhere. Okay. And now let's fill in the probabilities. Probability of rolling a 2 with 1 die is 1 out of 6. Times 2 minus 2 is 0. So it's kind of irrelevant, but I'm still doing that, right? Plus probability of rolling a 4 is still 1 out of 6. 4 minus 2, that's 2. Plus probability of rolling a 6 is also 1 out of 6. 6 minus 2 is 4. Okay. And then it's minus, what's the probability of losing here? What's that? Half. Or look at this, 1 6, another 6, another 6, that's 3 6, right, of winning. So another 3 out of 6 of losing, right, or half. So I'm going to go 3 out of 6 here, times 2. But you're right, it's half. 1 6 times 0, you can do it on your calculator, it's 0, right? So this is actually just 0 plus, I will do this as a decimal because it's going to save a lot of you because we hate fractions, right? So I'll just show you. You get 1 divided by 6, right, times 2. Trust me, it's not always going to be nice and clean fractions, okay? So we write down 0.15 0.33, and then we continue on. 1 divided by 6, right, times 4, that's 0.67. And then here, this is half, right? 3 divided by 6 is half. Multiply that by 2. Obviously, it's 1, right? You didn't need to calculate that, but I just want to show you that they are going to get pretty ugly, okay? So we go 0.33 plus 0.67 minus 1. So you just go through and add them up. You get a 0. You get a 0. So the expected value is $0. This means we break even. So should you play? Sure, you can if you enjoy the game, but just know that in the long run, not after 5 games, not after 10 games, but after like 100 games, you're going to end up breaking even, right? You're not going to win in the long run, okay? One more. There's not going to be a lot of break-even questions, I'm telling you that. So at least you've seen it. A home builder is putting a bid, right? There's a bid for a contract. The cost to put together the bid is $900. There are multiple components that you could be selected. There's a 25% chance that she'll be selected to do the framing. So that's like one way of winning the prize, quote unquote. And there's a profit of 12 grand. There's a 10% chance that she'll be selected to do the drywalling, mudding and painting, and there's a profit of 10 grand. 15% chance that you'll be selected to do the roofing, and you would make a profit or win, quote unquote, $8,000. Based on her expected value, should she put in the bid? So you weren't born in a contractor's family. Most likely your parents may not be in construction, but this is how it works. Just 1 minute, less than a minute. If you're a contractor and you want to tell the company, hey, I'm going to do it for this much, you can't just give them a price out of nowhere. You can't just say, oh, I'll do it for 10 grand, no problem. Because what happens is you just want to win that contract and you run into problems. It's going to cost you way more. And then now you have lied to them how much you're going to charge them. You actually have to do like a detailed calculation. Sometimes you need engineers, architects, all of them to weigh in and actually tell you how much it would cost. Materials, like you need to use bigger joists, like bigger wood pieces to support the weight, blah, blah, blah. So there's always a cost involved with you presenting it to whoever wants to hire you. That's where the $900 comes in. That's actually very cheap. A lot of times it's thousands of dollars. Like when they build the biggest high-rise we're going to have in downtown, I bet you that was like tens of thousands of dollars to present the project to the city or whoever ordered that project, right? Anyways, continue. Let's find our expected value here. The first way of winning, so this is like price 1, price 2, and price 3. There's 3 ways of winning in this particular scenario. By the way, this could have just said this. That's all they could have told you. There's a 25% of getting it, so there's a 75% chance of losing, of not getting the contract. But in this case, I gave you 3 different ones. So let's go ahead. 0.25, I will turn that into a decimal right away. You could be making 12 grand, but you paid $900, so that's your cost of playing. Plus, there's a 0.1 chance, or 0.10 I will do, right, of winning that other prize, which is 10 grand. You still would have had to pay $900 to play. And I'm going to run out of room here. Plus 0.15, and that's 8 grand minus 900. Oh boy. It's going to get ugly here, guys. Minus, I'm going to go choo-choo train off here, okay? Sorry about that. But it's actually more complicated than that. You need to kind of look at 0.25, 0.10, 0.15. And you always got to go 1.00 because there's 100% probability of everything happening. We're going to subtract those probabilities from 1 or from 100%. And what are we left with? 50, right? We're left with 50. So this is the probability of losing. They never told you that, but since these are the ways to win, if you subtract that from 1 or 100, that's 0.5. So 0.5 times 900. Yikes. I don't like that, but I don't have time to fix it. So let's clean this up. I urge you to clean this up, otherwise you're going to make mistakes. 11,100 plus 0.10. This is 9,100 plus 0.15. This is 7,100. And the last one is, you can leave it as is. If you have a pretty good calculator, you can actually type this now in all in one shot if you'd like. I will just stick with my method. 0.25 times 11,100. We have time, no problem. 2,775 plus. This one I know is going to be 910 because 10% of that. Just do your mental math there. This is 1,065. This part minus half of 900 is 450, right? And now I would do this in one shot. I wouldn't do it up there. You can, but if you'd make a mistake, you're going to lose a lot of marks there because you're not showing the steps. This is 4,300 plus, I should say. It is possible to get a negative. So expected value is greater than 0, therefore gain expected. So is it a good idea? It is a good idea to put in the bid. You might lose, but in the long run, if you keep putting in your bids, you would probably win in the long run. I'm just going to ask you to, on Monday, I have one AC that is just on this. That's going to happen on Monday. So I would like you to flip over to the next page, and I'll just give you the answers. If you want to practice, then at least you have the answers. So as you're writing this down, I'm just going to go find my key here. I need to find the key. And if I don't have it, then I'll post it. If I don't have it handy here, then I will just post it. Don't think I have it here. I may have scanned it already. Oh, no. There you go. So flip over to page 13. I'll just give you the answer. The expected value here is 0.08. And that means nothing if you don't do the work. Okay, so don't think like, I think I got it, right? Actually do the work. And the next one here, the expected value for this one on page 13 is 1.1. It's always dollars. So you need to have 2 decimals regardless, okay? By the way, one thing I forgot to tell you is that this is per game. That answer is the average per game. So if you play 30 games, which is a small sample size, so let's say like, but if you play 30 games, you're expected to get 30 times this, 50 times this, whatever it is. That's that because there's a question that asks you that. So this would be $22. This bottom question here. Okay. All right. If you want to review for test, right next to this, page 14, all the way to the end, there's like chapter test, old questions I've used in the past. Anything like that, you can use that.